Welcome to Big Data in 25 Minutes, a presentation by Synthetic Data. My name is Sharon and I will explain quickly the opportunities and challenges of big data as we see them in our company. I hope you find them interesting, so sit back and relax. Not long ago, storage and massive data processing solutions were very expensive, proprietary, and hardly scalable. However, with big data now we use cheap, highly redundant, scalable, and easy-to-operate servers. Again, before, we used proprietary, not quite adaptable, expensive, and hard-to-maintain software. Now with big data, we use software which is highly scalable, open source, free, and highly specific to each industry. Still before big data, database solutions were based on the previous creation of fields with a rigid size and format, creating limits in their scalability and in the format of the data to be stored in them. With big data we now have the so-called NISQ databases. These are created in structures of variable size, which can thus receive data in any size and format. However, the end result of all that is that the amount of data grew exponentially, confirming the need to store and process massive amounts of data quickly and inexpensively. Still, the original problem remains and got even worse, which is the fact that data arrive with volume, velocity, and variety, but still need veracity, the so-called 4V. In this, big data is in our vision really the central part of a three-level pyramid: data capture, IoT, storage and processing, big data, and data analysis, AI. The base of the pyramid is IoT, or the Internet of Things. It is made of thousands of devices, sensors, etc. which capture data and transmit them over the Internet or other networks. Thus, IoT generates the data which will be processed. In the middle we find big data, which is responsible for storing and processing the data obtained by IoT, so they can be then analyzed by AI. Finally, the top is AI. Artificial intelligence is about finding patterns in the data captured by IoT and stored/processed by big data, to be able to predict the future and thus react accordingly. In the picture for example we have a Hari Sheldon, a fictitious character created by Isaac Asimov, who could predict the future with math formulas. But the most striking effect of big data is that, just like the Internet allowed a small enterprise to compete with large ones in foreign markets, big data will allow it to know its processes and customers as well as the large ones and, again, compete effectively. Again, just like the Internet showed the need of a multidisciplinary team which included marketing, management, etc., the same happens with big data, which generally use 1 sysadmin and sysops, 2 programmers, 3 mathematicians and statisticians, 4 system architects, 5 marketing managers, 6 etc. Now for some examples. In the first, all of the power grid in Spain shall have smart meters before 31 of December of 2018, as required by the government. Thus, an effective implementation will mean a huge amount of data, as each smart meter is expected to send data every 20 seconds. An example is Power company Endesa is leading the change in Spain with over 3.5 million meters installed, over 30% of its client base. Similarly, Swedish company Sweco processed 5 billion lines of 200,000 clients in 3 years. The benefit is that it allows following in real time the level of usage of the grid, redirecting power as needed. Also, it allows predicting the increase in power needs, thus proactively increasing the equipment required to handle the future load. Another example is how in 2010, 1.5 million people saw a video promoted by Greenpeace on how Nestle's Kit Kat chocolate bar was in fact killing orangutans. The company only reacted after receiving over 200,000 emails protesting, and tried to erase the video and the comments in YouTube. Today Nestle uses sentiment analysis, which allowed it to move from the 16th to the 12th position in the most respected company index in the world. Similarly, Exxon developed with IHS a system which analyzed over 20,000 tweets the public's opinion on fracking. The benefits is that it increased the company's corporate image and thus the amount of customers. Another example is the city of Boston, which was able to eliminate potholes in its streets thanks to an app which reads the user's mobile accelerometer and thus identifies each time his car hits a pothole. The benefit was reduction in fuel use, increase in the city's fleet time, decrease in the amount of fraud and fines, and an increase in the city's image by tourists. Finally, another example was company T-Mobile, which developed a system which calculates the customer lifetime value based on 3 variables: billing analysis, drop call analysis, and sentiment analysis. The end result is that churning decreased by 50% in only 3 months, which led to a reduction in the amount of customers lost, increase in market share, and increase in customer satisfaction. Sadly, however, most part of the big data implementations today are the simple gathering and storing of data without any need or focus. In this picture, we have an episode of the famous TV show South Park, where gnomes collect underwear to make money off of them, but without knowing how, much similar to how we do big data today. In fact, study from December 2013 by Teradata found out that half of the companies do not know if they actually got any benefit from big data. And that hasn't changed. Later study of November 2015 by PwC showed that only 4% of the companies actually obtain benefits of big data. Also, the huge growth of the amount of technologies available created a deficit in the amount of qualified professionals and a large increase in their salaries. Finally, most of the companies still program for first generation, when we are already at the 4th. This means coding with obsolete technology which takes almost 3 times the amount of time a modern solution would require and which will soon have to be replaced anyways. All this leads us to some interesting conclusions, namely, 1. Big data is not about just storing data, but about finding trends to allow more revenue, less costs, and better service. 2. For that, big data allows the development of highly stable, scalable systems at a minimum cost. 3. Big data thus allows small enterprises to have technologies which only large ones could afford, thus providing them with the tools to effectively compete. 4. However, big data requires a highly specialized and diverse team which does not limit itself to the TI folk and, thus, should be led directly by the company's manager. 5. Thus, big data see not just a fad destined to a few chosen ones, but a new technology which in a few years will be available to everyone just as it happened with the internet. We hope this presentation was enlightening and we welcome you to know us at www.syntheticdata.eu. Thank you for your time.